In the figure, ABCD and EFGH are squares with AB equal 2 centimeters. E, M, and N are midpoints of the sides AD, AB, and CD respectively. Find the area of pentagon AFGHD. So first, pentagon AFGHD, we can draw that in. That's going to be, draw that side in there, side in there. That's going to be this figure here. Okay, this pentagon. We're going to find the area of that pentagon by breaking down, finding smaller pieces of that area, starting with this square. So to start, if we just look at, first, I just want to find the side length of this square, so I can find the area of the square. This side length HN, we can write out the following right triangle like this, where we have N, H, and C. And we know that NC is 1 because N is the midpoint here. And then it's also going to be true that since this is coming with the same slope as this, and this is a 90-degree angle because this is a square, it has to be true that these are two 45-degree angles, so these side lengths have to have the same measure. And since we have a 45, 45, 90 triangle, it must be true that this side length times root 2 will equal 1. So it's true that 1 over root 2 times root 2 is 1. So HN therefore equals 1 over root 2. So next, to find the measure of NE here, we can do same thing, use the Pythagorean theorem. So NE, and we know that these side lengths here, this is a right triangle, are 1. And so using the Pythagorean theorem, 1 squared plus 1 squared, we'll call this x squared. So 2 is equal to x squared, for x is equal to root 2. So therefore, it must be true that NE is equal to root 2. So now we can find the area of this square. And the area of the square is going to be, we're going to square each side length, and each side length is going to be HN, which we found was 1 over root 2, plus this NE, which we found was root 2. And so square that. We can simplify this in here, get them to have the same denominator. Root 2 is just 2 over root 2. We multiply numerator denominator by root 2. And we get 9 over 2 is the area of that square. So we found the biggest component of the area of the pentagon. Next, I want to look at these triangles here. Is another component of the area of the pentagon. So these triangles, we can see they have base of 1 and height of 1. So the area of those triangles is 1 times 1 over 2, which is 1/2. And since we have 2 of them, we'll do 2 times 1/2 is 1. So lastly, the area of the pentagon that we want to find that we haven't calculated yet is this area here. This triangle here, the area DNH, that triangle. And this is an interesting one. So what I did here was, if we focus in on this triangle, we can make that into a parallelogram like this. And so we have a parallelogram like this. We know that this one side length is 1, but we don't know the height. Area of a parallelogram is just a base times height, so we just need to find out what the height is, h. But we can find that if we just look at this right here. We can create a right triangle. Basically, the height of this right triangle here, where HN is the hypotenuse, that measure is the height of this parallelogram. So we know HN is 1 over root 2. And it's going to be true that these have the same these have the same angle measure, because this was a 90-degree angle. This split it into a 45-degree angle. We know this is a 90-degree angle, so this must also be a 45-degree angle. So this is a 45, 45, 90 triangle, and so it must be true that this side length times root 2 will give us this here. And so that is going to be, this side length then is 1/2. 1/2 times root 2 is 1 over root 2. So just make sure that 1/2 times root 2 is root 2 over 2, which is the yes, okay. So that's correct. So this side length must be 1 over 2, and you can check that by the Pythagorean theorem. So therefore h is equal to 1/2. And then therefore the area of that parallelogram is base times height. Base is 1, height is 1/2. It's 1 times 1/2. But we want to find half of the parallelogram. So area of both parallelograms is going to be 2 times, this is 1/2, 2 times 1/2, which is 1. But we only need to find half of since this is the diagonal, we only want to find half the area of the parallelogram. So we'll take this, 1 is the area of the two parallelograms. We want half of that. So area of the parallelogram halves is simply 1/2. And so these are the 3 components of the pentagon area that we've found. So therefore the area of the pentagon is just going to be 9 over 2 plus 1 plus 1/2, which is 6.